Oliver is powered by a 120-volt AC input from a standard wall socket. A 9-amp fast-flow fuse and emergency stop button are wired in series to this external connection. Power then flows into a 3-port distribution strip with an internal 5-volt USB power supply. The first output goes to a 24-volt power supply responsible for Oliver's 4 stepper motors. The second goes to a 12-volt general-purpose supply responsible for system cooling, pumping, and Arduino power. The third output goes directly to the drill. The Oliver frame is built out of 80/20 extruded aluminum, incorporating some 20/20 and 20/40 elements. The drill frame is also made of 80/20 and is mounted to the main frame by using a combination of brackets and sliding rails. Oliver's drill is a commercially available Makita HP 2050 rotary hammer drill. The selection of this drill, with its hammer mechanism, gives us extra leverage to fracture consolidated overburden layers and ice. The drill itself is actuated by a pair of servo motors mounted onto its chassis, one of which adjusts velocity and the other switches direction. Oliver uses an SDS Max form factor drill bit, which is mounted to the Makita drill using a modified chuck adapter. The drill bit itself features auger flanges and a carbide tip, and is encased with an aluminum pipe sheath. Both the adapter and chuck are stabilized using 3D printed pieces. The drill carriages are also 3D printed and are connected to each other by 6 threaded rods, encasing and holding steady the Makita drill. They also hold 2 arrays of load cells, one located behind the drill in line with the drill bit, and another at an interface point between the drill carriage and the lead screw. The drill frame is actuated both vertically and horizontally by a lead screw system. One of the 2 Arduino Megas on board Oliver is responsible for stepper actuation throughout the system using 4 DM542T stepper drivers, which run the X and Y steppers as well as the agitator steppers. Knowledge of the robot's position is maintained via step counting with a home basis. In the homing process, each part of the assembly moves to meet its respective limit switch, setting the system at a known state. The system is inaccessible during the homing process to prevent interference from invalidating the home command. Once the drill reaches ice, the drill sheave is released from the bit to stabilize the borehole. The extraction system consists of a modified servo rail actuated by a continuous servo. This is mounted to the drill carriage by 2 aluminum plates, such that the sliding rod is parallel to the drill. The rod falls of its own weight and is raised by reversing the continuous servo, pulling on a string connected to the bottom of the agitator mount. The agitator is mounted at the base of the sliding rail, along with a stepper motor that allows it to open and close. The agitator is comprised of 2 aluminum scrapers wired through with an electrically insulated nichrome wire. The nichrome wire is run at approximately 45 degrees Celsius using 2 amps and 6 volts, heating the agitators. 1/8-inch inner diameter vinyl tubing is used to extract the water, which travels through a wire mesh into a carbon block filter. The water is then run through the pump and a 1/4-inch inner diameter vinyl tubing to empty it into the collection chamber.